Hello and welcome back to another New Horizon Tutoring Math video. Again, if you don't remember, my name is Liz and today we're going to be going over just that, some more math. So we're going to be working specifically out of the packet, so you're definitely going to need that today, as well as just whatever notebook you've been working out of, your graphing calculator, something to write with, obviously. So yeah, we're going to jump into it. Today's primarily going to be note-taking, so make sure that you're writing down everything that I write down on the board, anything that I say that kind of makes sense or resonates with you. And we're going to be tackling kind of a tricky topic. It's a lot of tongue twister tease. Anyways, we're going to be tackling kind of a tricky topic. It's going to be trig. So I remember when I learned trig, whether it was through kind of like Minoja's classes or when we first started talking about it in school in like basic terms, I personally could understand the concept of like different trig functions, right? So I don't know where you guys are kind of at with your trig journey, but we're going to start at the very beginning, just so that I can explain the basics to you and explain the reasoning behind it, because that's something that I never really got. And so it was difficult for me to understand because I didn't get the logic behind it, because like I wasn't taught it, so I didn't really know it, obviously. But as I was saying, I could understand kind of like the concepts of trig functions themselves. So if you already know this, but like sine, cosine, and tangent, based off of a right triangle, you're taking different numbers over each other. There's stuff with angles. I could kind of utilize those basic functions if the question was easy enough and like simple enough, but I never understood like really what I was solving for. I could plug stuff in, but I didn't get the reasoning behind it. And that's not what I want for you guys, because it might get you a couple points on the ACT, might get you a little bit further ahead in your math career. But if you don't understand the logic behind it, you're not going to be able to, one, apply it to harder problems, and two, it's going to be more difficult for you to retain in the long run. Whereas if you're taught the basics now and understand the logic behind it now, it's going to be a lot easier to get those harder questions. Yeah, it's going to be a lot easier to get those harder questions right. I almost said wrong. We don't want to get questions wrong. It's going to be a little bit easier for you to like understand relationships behind the problems and understand what we're actually doing, so that it's less memorizing and more understanding, which is always what we want, right? Obviously there is kind of like a little element of memorization in it, but it's really not too bad. Just like some functions that you have to remember. So with all that being said, kind of a long intro, but we're going to go ahead and jump into notes. So yeah, I'm kind of going to be like recreating some stuff on your packet, so definitely follow along there. But I'm also going to be writing down some stuff that is not on your packet that I think is going to be really helpful to your understanding. So definitely write that down as well. Okay, so what I wrote up there is essentially the definition of what a trig function actually is. Not necessarily what trigonometry is, because trigonometry is more of like a certain section of math in general. But I just think it's a little bit more helpful to like focus on what trig functions actually are. We're going to get into like the specific trig functions and stuff like that in a little bit, so this is going to make a lot more sense, but I definitely think it is very important to at least talk about this. So when I say trig function, what do I actually mean, right? I'm just going to go ahead and write one trig function up here. You don't have to write it down. But when I say trig function, an example would be like sine of theta, right? When I say trig function, I'm referring in this case to sine. All of my trig functions, there's really going to be like three main ones: sine, cosine, and tangent, if you don't already know them. All of my trig functions are going to be operations. So what do I mean by an operation? Well, an operation is kind of just like a mathematical tool, right? So different operations would be like multiplication, division, addition, subtraction, stuff like that. So it's not an actual like value, it's a function that we're using. And that's also why we call them trig functions. Functions, operations, kind of same thing. So, and you'll see this in a little bit, but where people kind of get confused is when they don't understand what trig functions actually are in their essence. So it's kind of just like a more complicated multiplication or a more complicated division. Not that they have similar features, but that it's like under the same category of an operation, a mathematical operation. So let's say that I wanted to find whatever theta here was, right? A lot of people assume that the sine and the theta are being multiplied together, because that's kind of what it looks like, right? It's like if we had 2 theta here. It looks like they're being multiplied together because they are, but that's not what's happening in sine theta. We're not multiplying sine and theta because sine is an operation. So we can't multiply by an operation, right? That'd be like trying to multiply by division. You can't. Division is like something that you do, it's not a value. So when we think about stuff like the sine of theta, don't think about it in terms of being multiplied because they're not. Sine is just a different type of operation. You'll see how that works a little bit more clearly. But what some people will try to do in order to find theta, if that's what we want to find, and we'll have values here for our opposite and hypotenuse, they'll try to divide by sine. Because again, they think that they're being multiplied together, they're doing the opposite, but that's not correct, not correct. So like I said, don't write that down. But that's just kind of like giving you an introduction and another way to kind of get that into your head that like, okay, trig functions are operations. I can't really deal with them in similar ways that I would with like simpler mathematical equations. So just keep that in mind as we go forward. Trig functions, sine, cosine, tangent are operations, just like multiplication, division, stuff like that. Okay, so, and as you can see here in my little definition, we're specifically dealing with right triangles when we're dealing with trig. So what I did here is just drew like a basic right triangle, and we're gonna go ahead and essentially kind of label this in terms that are gonna be very helpful and basically essential to figuring out like how we actually deal with trig. So the first thing that I'm gonna talk about is what I call theta. It's like this weird symbol, looks like an O with a line through it. That's going to be theta. Basically, it's just another variable. So we could put like X here, or Y here, or any other symbol. For some reason, don't know why, mathematicians just decided to use theta when we're talking about angles. So whenever you see theta, you're probably going to be dealing with an angle. So kind of another way to think about it is that your theta is going to be your reference angle. And reference angle, that name for it is pretty self-explanatory. But when we go to actually label our triangles, or like label the different sides of our triangle, it's all going to be in reference to theta. So your 90 degrees is never going to be theta. You don't have to worry about that. But your theta could also be this angle up here, right? It just depends on the information that they give you. But the labeling of your triangle all depends on your theta, and we'll see that in a little bit. Okay, so I just wrote these kind of 3 words up here. They might seem meaningless to you now. That's totally fine because we're going to explain them. So we have our opposite, our hypotenuse, weird, and our adjacent. And what these are all labels for the sides of our triangle. So these are all side labels. 3 side labels, 3 sides, makes sense. But we're gonna go ahead and figure out what label applies to which side depending on our reference angle, right? So that's kind of where we get that interplay. It is in reference to our angle, and again, denoted by theta. So the first one that I'm going to look at is actually my hypotenuse. So your hypotenuse of a triangle, and this, like the term hypotenuse, you probably have already heard it in dealing with like the Pythagorean theorem, a squared plus b squared equals c squared. Your hypotenuse is always going to be your longest side. So it's always going to be opposite that 90 degrees. So this is going to be your hypotenuse. Your hypotenuse honestly never changes depending on your reference angle, which is kind of nice because it's always going to be opposite that 90 degrees. It's always going to be the longest side. So that is your hypotenuse. We're left with 2 other sides, right? Our opposite and our adjacent. And their names kind of give away their position, which is nice. It doesn't require much memorization if you just kind of like think about it logically. So we're going to look at our opposite side. Our opposite side, denoted by O, is going to be whatever side is opposite our angle. Makes sense, right? So this side is directly across from or directly opposite to my angle, so that's going to be my O side. And then I'm left with A, and only one side, so it's pretty obvious which side is going to be A. And by A, again, I just mean my adjacent side. But even if you think about what adjacent means, it just means next to. So this side is right next to my reference angle, right? There's 2 sides that are kind of right next to it, but my hypotenuse is already taken. So it's going to be the other side that's next to or adjacent to my reference angle. So yeah, that's labeling the triangle. Again, it's always going to be in reference to theta. Always 3 different sides, opposite, adjacent, hypotenuse. And this is honestly a really big step kind of just in trig problems in general. I guess you could call this kind of step number 1. And if we have time to go over questions today, you'll see exactly how I integrate like the different steps into an actual problem, but we're definitely gonna have time to like revisit trig in the future. So if we don't get to specific problems today, don't sweat it, we'll cover it later. But yeah, that's kind of the first step, just labeling our triangle. If you haven't figured it out by now, I'm a very big proponent of like labeling things and drawing things out and diagramming them, and basically translating the information that they give us in word form onto like a mathematical diagram or into a mathematical equation, just because that's how we actually work with it, that's how we visualize it, stuff like that. So yeah, and also it's just important that you know how to do this, because this is, like I said, our first step. If you don't know how to do this, or if you do this incorrectly, you're gonna get your answer wrong, which we don't want. So step number 1, make sure that you kind of understand the concepts behind this, and understand like why we're doing what we're doing. That's the most important thing. Okay, so I'm gonna go ahead and erase some of this so I have some more room. Okay, so for now, we're going to talk about the 3 main trig functions. There kind of are like 3 other derivative ones, or like 3 other side functions that we are going to talk about, but for the most part, these are the ones that you're going to know, and these are kind of like the basics that we want to talk about first. We want to get these down. So there's 3 different trig functions. Obviously, I wrote them up there. The first one is sine theta. Second one is cosine theta. Oops. The next one is tangent theta. Those are kind of just like their actual names written out, but when we deal with them in mathematical equations, we kind of write this shorthand, sine, cosine, tangent, like that. So yeah, these are our three different trig functions. And again, think about trig functions as operations. So all of these operations are doing different things. So again, this is just like a very loose analogy. Don't take this too literally in so much as, oh, these are what the functions are actually doing. That's not how it works. But just think about them as three different mathematical operations. So like multiplication, division, addition. Those are three different mathematical functions. Obviously, these are three different mathematical functions. So they're gonna do different things. And we'll see that in a little bit, but again, just calling back to our original definition, that's what those, or that's what these silly words and symbols mean in their most basic form, which is basic, but important to know, important to remember, especially if you do get confused with trig in general, because it's kind of a weird topic. Okay, so I just mentioned how like these are three different trig functions. They're all going to do three different things. But in general, what they're going to do is they're going to fulfill what I talked about in our definition up here. They're basically going to look at ratios of sides in right triangles. So I'm just going to go ahead and kind of finish writing out these trig functions here. Okay, so our first one, sine theta, is going to find the ratio of the opposite side to the hypotenuse side. Or you can just say sine theta is equal to opposite over hypotenuse. But if you think about it like in its core, that's what the opposite over hypotenuse is finding. It's finding the ratio of the sides. So it's basically comparing two sides to each other, right? And it's doing the same type of thing with cosine and tangent, but as you can obviously tell, it's dealing with different sides, right? So that's kind of where like the different functions or the different operations come into play. They're doing like the same general task of taking ratios of sides, but they're using different sides, so they're getting different ratios, obviously. So with cosine here, we are finding the ratio of the adjacent side to the hypotenuse side, and with tangent, we're finding the ratio of the opposite side to the adjacent side. So with all of that in mind, now if we look back to our triangle, it's obvious, like it becomes a little bit more obvious as to why it's so important that we label our triangle correctly, right? Because like these actual measurements are gonna stay the same. Like let's say this side is 4, or let's say this side is 4, this is 3, this is 5. Depending on how I label the triangle, with my opposite, my adjacent, my hypotenuse, the actual measurements are going to stay the same, right? They're not going to change just because we change the label on it. But it is important to like label it correctly, obviously, because those sides aren't going to change and we want to know the actual correct relationships of them. So yeah, here we have our three basic trig functions. There's kind of like a cheesy acronym to remember it. SOHCAHTOA. I personally never remembered it that way, just saying like sine, opposite, hypotenuse, stuff like that. I remembered it, what was it? I think it was some old horse came hopping through our alley, which I mean, like when I first started, I literally had to like repeat that to myself so I would remember it. And that's kind of like where part of the memorization comes in. But however you want to remember this stuff because it's very important. But like I've been reiterating, it's also very important to understand kind of like the logic behind it. So yeah. Another really important thing that I kind of just want to touch on briefly, we'll find it a little bit later. You're using these operations to find the ratios of sides, not to find the actual side measures. So I'm just going to put some labels on here. Okay, so I just labeled that triangle with actual sides. We have 3, 4, and 5, same ones that I used like 5 seconds ago. And I'm just gonna kind of show you like how you would fill in these 3 different trig functions depending on that triangle. It's really easy, honestly, but I also think that like, anyone can plug in 3 for O, right? It's like plugging in 2 for X, if they tell us that X is equal to 2. But what's more important is to understand kind of like the main definition and how it's ratios of sides that we're finding, not actual side measurements. Okay, so like I said, these 3 functions that I just wrote down are in specific reference to this triangle. Again, following like the same basic relationships here, just filling in stuff. So we have sine theta is equal to 3 over 5, opposite over hypotenuse, right? Cosine theta is equal to 4 over 5, adjacent over hypotenuse. And tangent theta is equal to 3 over 4. 3 opposite over 4 adjacent. So that just shows you specifically why it's going to be, or like how it's going to be ratios of sides and not actual side lengths, because we're not saying that like any of these side lengths is equal to 3 over 5, or like 3/5 of a unit. That's not what we're saying. We're saying that we found the relationship between these 2 sides, and we can represent it as this ratio or as this fraction. Same kind of thing, just thinking about it 2 different ways. So yeah. Important to know, again, it's ratios of sides, not actual side lengths. And it's like pretty, like that seems obvious right now, obviously. But it'll get more important, and you'll kind of see why I keep reiterating that as we get into some more practice. So yeah. Okay, so the next thing that we're going to briefly talk about is what we call inverse functions. So I technically am going to be writing 3 totally different trig functions up on the board. But they have each one of these new trig functions that I'm going to write on the board has a direct relationship to one of the other trig functions that we already talked about. So that's why I say that like these are the basic 3 that you have to know, and these are kind of like derivatives of them. But it definitely still is important to know these because you'll see them not so much, I would say, in solving like basic trig problems, but you will see them just like in trig in general. And the concept between the 2 really is not too difficult. Okay, so these are the 3 inverse trig functions, we call them. You'll see why we call them inverse trig functions in a second. But this first one is cosecant. The second one is secant. And the third one is cotangent. So, like I said, each one of these is gonna kind of like pair, if you want to think about it that way, to like one basic trig function that we already talked about. And it's kind of annoying. Just make sure that you keep this clear. It seems like sine should be related to secant, and cosine should be related to cosecant. I don't know why whatever mathematician determined this. I mean, like, good for them, obviously, but they really could have made it easier on us in terms of like remembering. But just make sure that like you know that these are the actual relationships, even though it seems like cosecant should go with cosine and sine should go with secant. For some reason, they made it not that way. So yeah, kind of annoying for us, but just remember it, I guess. Again, that's just something with math that you have to remember. And again, these are kind of just like their names written out. So now I'm going to go ahead and write down what the actual relationships of each of these inverse trig functions is. Okay, so just wrote down kind of like the fulfillment, I guess, of each of these trig functions. And now it's probably going to be a little bit more obvious for you to see why each of these inverse trig functions are paired up with a basic trig function. Basically, all we're doing here is we're flipping the fraction, right? So like for sine theta, we have opposite over hypotenuse. For cosecant theta, we have hypotenuse over opposite. So we're taking that fraction, we're taking that ratio that we found, and we're just finding kind of the opposite of it, or another word for that is inverse. That's why we call them inverse trig functions. So like I said, you're really just switching the numerator and denominator. So like I said, cosecant theta is equal to hypotenuse over opposite. Secant theta is equal to hypotenuse over adjacent, and cotangent theta is equal to adjacent over opposite. So yeah, like I said before, you're going to be dealing more primarily with these basic trig functions, but still make sure that you understand the logic behind how we get inverse functions, and then be able to like write down all of these specifics in there. Okay, so something that I also want to touch on, that I haven't yet and is super important, is writing out each individual function and the way that we kind of have to do that. So as you can see, when I wrote all of these down, I always wrote sine theta, cosine theta, right? Tan theta. You always have to do that. Sometimes people will mistakenly, let's say for this triangle, right, like tan is equal to 3 over 4. But that's technically incorrect because tangent needs to hinge off of that reference angle. You can kind of think about it as like, I don't know, I can't come up with a good analogy right now, but it just requires that reference angle. You have to write that reference angle in there. If you don't write that reference angle in there, it's going to be incorrect. Writing this technically doesn't make sense because it needs that reference. We don't know what it's in reference to. Because we could say that like this angle up here is like alpha or something. That's just another variable. Then if we wrote tan is equal to 3 over 4, we don't know what angle it's in reference to in this triangle, right? We don't know if it's theta or if it's alpha. So just make sure that you specify what angle it's in reference to. And again, that'll kind of take on like a new layer of meaning as we get into some more difficult questions. Okay. Honestly, I think that's about all I want to say for trig for now. But I do briefly want to kind of cover the rest of the steps because I talked about step number 1, didn't talk about the rest of the steps because it didn't really fit into what we were specifically talking about. So we're going to go over them now. And then I'm just going to do like a basic walkthrough of an example for you guys. We're going to take it super slow just so that you are able to translate what we just did into the actual problem that we're going to be doing, because obviously that's super important. Okay, so like I said, step number 1, label our triangle. That's not even like really dealing with the trig functions themselves yet. You're just like taking whatever your reference angle is, whatever your theta is, and you're labeling your 3 sides, right? Opposite, hypotenuse, adjacent. Not too bad. So your second step when you get into an actual trig problem is going to be transferring your information, transfer your info. That's basically what I kind of did up here. We just didn't really talk about it explicitly in these terms. But by transfer my info, I just mean like put whatever side measurements they give you onto the triangle. So I just came up with these, but like 3, 4, and 5. In dealing with trig problems, they're usually not going to give you 3 sides. They're usually going to give you like 1 side and ask for another side, or like some kind of sort of a problem like that. But regardless, it's just important to like transfer whatever information they give you onto the triangle. And let's say that they were like asking for the hypotenuse. Even though we're asking for the hypotenuse and they technically don't give us any specific information about it, we just know that we need to find it. Since that's what we need to find, just denote that with any variable. I typically just choose x, and you'll see why in a minute. Okay, so mentally we're working through this trig problem, right? We labeled our triangle. We transferred our actual information onto our labeled triangle. Now is when we get into our actual trig functions. And before we write down anything dealing with trig functions, we need to figure out which one we're going to use. Hence, me writing down determine trig function. And basically what you're going to do is you're going to look at all of the information that they give you on your triangle, right? And you're going to look at the information in kind of two different ways. One, what you know, and two, what you want to know. So like I said, in this specific scenario, I want to know h. That's why I put x there. So now I'm thinking about what trig function I can use depending on what information they give me and what information I need to know. So I'm going to pretend like I didn't know O is 3. I'm just going to say that they give me 4 is A, and I want to know h. That's why I call it x. So if I look at my trig functions, again, just focusing on these ones, don't focus on our inverse trig functions for these because we can do it with the basic stuff and that's easier. Just looking at my triangle, I know that I'm dealing with A and I'm dealing with h. So I know that the specific trig function that's dealing with both of those sides, A and h, is going to be cosine theta in this specific scenario. So then, if I was just kind of like working through this problem, you don't have to do this on the actual test, but if I was just like working through this problem in general, I would write down this basic relationship here. Cosine theta is equal to adjacent over hypotenuse, especially if you're just starting trig. That's going to be really helpful in just kind of like determining what you need to do and like visualizing it. And yeah, obviously it's just something that you like kind of have to memorize. So if you don't have it memorized yet, just writing it down would be helpful. Okay, so then step 4, you're basically just going to plug in your info to your basic trig function. So in this case, we're dealing with cosine theta is equal to adjacent over hypotenuse. So I would say cosine theta is equal to 4 over x. Again, just plugging in by info, I mean either like side measurements or angle measurements, stuff like that. And then step 5 is going to be to solve. In essence, we're solving like we would any other mathematical equation, right? We want to get whatever we need to find alone. We want to get x alone, or we want to get theta alone. But since these functions, these trig functions, are different mathematical operations than we've been dealing with, different from like addition, subtraction, stuff like that, it takes a little bit of kind of reworking, and that's where you need your calculator to come in and do the work for you. It's not something where you can just like do it in your head, unless you like remember specific relationships, but we're not doing that here. That's dealing more with like calculus and stuff, so if you aren't there yet, don't worry about it. You can, trust me, you'll have plenty of time to worry about calc when you actually get to it. So yeah, that's kind of just like the basic run through of how you're gonna solve most trig functions, most trig questions. So now I'm just gonna at least set us up and at least go through a couple of steps depending on how much time we have for like an example trig problem. Okay, so wrote this problem up on the board. This is going to be your most generic trig problem. They give you, it's a right triangle obviously, they give you one side, they give you the measure of one angle, and they ask for the measure of another side. And this also kind of just gets down to like why we need trig in general, because if we were dealing with a right triangle and we knew two sides and we wanted to know one side, we use Pythagorean theorem, right? We already know that. But here they're giving us different information. They're giving us a side and an angle. Can't use Pythagorean theorem for that, so we use trig. So I'm basically going to walk through kind of the, I think it was like 5 steps that I wrote on the board, at least kind of like the preliminary ones, just setting us up for thinking about this problem in the most efficient way, so that you guys can kind of like start to replicate this stuff in your actual practice. Okay, so if you remember, step number 1 is going to be to label our triangle in reference to whatever angle we're dealing with. So this technically isn't my theta because I know it, but it's going to be my reference angle, right? This 30 degrees that they give me. So I have 3 different sides that I need to label: opposite, adjacent, hypotenuse. I know that this side is going to be my hypotenuse, opposite the 90 degrees, that's the longest side, got that one down. I know that this side is going to be my opposite because it's opposite my reference angle. And then lastly, I know that this is going to be my adjacent side because it's the other side other than the hypotenuse that is right next to my angle measure, my like reference angle. So yeah, that is my triangle labeled. So really, we don't have to like transfer any information that they give us from like the text, because there isn't any text. They already like did that step for us. They transferred the information onto the triangle, which is helpful. So now what I'm going to do is I'm going to look at the information that they give me and the information that I need to know in order to determine what trig function I'm going to use. So I know the length of my opposite side, right? And I want to know the length of my hypotenuse side. So if we're thinking about what specific trig function deals with our opposite and our hypotenuse side, it's going to be sine, right? Not too difficult. We know that the basic kind of formula for our sine function is sine theta is equal to opposite over hypotenuse. Those are the 2 sides that we're dealing with, so that's how we're going to find our information. So now that we have that basic trig function figured out, we can just plug in the information that they give us. And this is also kind of why I referred to 30 degrees, the angle that they give me, as theta, because instead of writing theta here, we now have that angle measure, right? So we're going to actually like specifically plug in our angle measure there, and then I'm just going to plug in 4 for my opposite and x for my hypotenuse. And then this is kind of more of like my specialized function, if that makes sense. So then I want to solve for x, right? So, I mean, I guess you could like multiply both sides by x and then divide by sine 30. But if you don't already know this, if you have like x or you have a variable that you want to find in the denominator and it's set up equal to this, you can really just like switch whatever value is over here into your denominator and your x switches over here. So our x is equal to 4 over sine 30. And yeah, honestly, sometimes the ACT will even leave it like that. Sometimes I'll actually solve it out. I'm going to leave kind of solving it out for next time just because it deals with like specific stuff with our calculator that we don't have time to get into now. But yeah, that's kind of just like a basic crash course on trig. And we're able to walk through a problem, which is helpful so that you can hopefully kind of replicate what we did into any practice that you do by yourself. Again, just really try to get back to the basics. Understanding like the fundamentals of trig is really going to help you in solving these problems in general. Okay, so we are at time, so we're going to call it a day, and I will see you guys next week.